Hello, and welcome to my presentation, Cosplay Electronics for Beginners, or How We Learn to Love the Arm. This presentation will hopefully give you a basic introduction to electronics and how to use them in your costumes and props. So, who am I? Well, my name's Sam, or Sciencegey if you're one of the cool kids. I work in IT, so I'm horrendously unqualified for this presentation. I mainly work with servers, which, may conjure images of nice clean server rooms like that thing up there. Nice Ethernet cable, by the way. However, it's not quite like that. It's more like this, if I'm honest. And I do electronic stuff sometimes. When I started out by getting an original Raspberry Pi as a teenager, and progressively got more and more ambitious and crazy with my ideas. And in all of those cases, I've never really had a clue what I'm doing. And yeah, I've made some things. And these are some of the things. Going from the top, we've got Steve the Protogen, an overly complicated Protogen helmet made out of a 3D printed frame, vacuum formed visor, lots of LEDs, like the big kind of panels that they use on video walls, and lots of very complicated electronics, as you can see in the bottom. Then there is Spot Micro, that blue dude there. He's a small-scale clone of the Boston Dynamics Spot robot, and if I'm completely honest, I'm no NS smart enough to get it to work properly. But it's a thought count. And a clock. I mean, it's a clock. It tells the time. It was my first kind of proper project. Uses a real-time clock module and an Arduino to tell the time. The things that clocks generally do. And other stuff that is either too small to count, or I unfortunately don't have pictures of. I mean, I kind of lied. All that stuff there. So, you may be thinking to yourself, Sam, electronics is scary. And I might blow myself up. And you'd be kind of correct. But the thing is wearables are a big market nowadays, which means there are loads of components out there that are both easy to use and affordable. And to go with that, there's lots of resources out there to help you use those components to make really cool things. I mean, my personal favorite, Adafruit, Spartan. However, there are so many websites and YouTube channels dedicated to electronics that it's impossible and would frankly be unfair to some to list them all. And the thing is, it's really hard to actually blow stuff up if you just RTFM, and there's a personal favorite of mine, servals. They make it really easy for you guys to create and wire all kinds of cool, crazy costumes. I'll go back to them later. So, how do I electronic? Oh, yes, how do I electronics? It's pretty simple, actually. I mean, like, literally, it doesn't have to be super complicated. I mean, yeah, something like building a Protogen head is really complicated, but you don't have to build something like that. The thing is you can create lots of cool effects with just basic skills and components. For example, something simple is glowing eyes, right? They're actually really easy to do. And I mean, if you can make all these like cool costumes and stuff, I'm pretty sure you can make some eyes glow. So you may be thinking to yourself, what are electronics? And while it's a very deep question and one that I would still be answering for probably the next 6 hours, I don't have that much time, so I'm going to give you a crash course. Basically, electronics are magic. Well, the kind of, I mean, as the great Arthur C. Clarke once said, any sufficiently advanced technology is indistinguishable from magic. But in basic terms, an electronic device is something that uses components to control the flow of electricity and getting something useful out of that. Whether that's your phone, your car, or even this very VR headset you're wearing right now. They're all related because they're using electricity to do things, right? Now, how it works is super complicated, but basically, electricity flow is the flow of electrons around a circuit, right? That's shown up there. The flow is known as current. In this case, the current flows out of the positive terminal of the battery through the lamp, or load as they're known, which then turns, in this case, into heat and light. And then it goes back around, back into the bottom of the negative terminal. An intuitive way to think of electricity is kind of like water, in that the voltage is the water pressure, and the current is the size of the pipes, and the resistance is like closing the tap a bit. So, now to something a bit more interesting. Lights. The thing is most of your projects will probably involve lighting in some way, shape, or form. It's easily the most eye-catching part of the costume. Unfortunately for you guys, there's loads of different types of lights available. And while it may seem like a good idea to just hop onto AliExpress right now and all of the coolest looking ones, don't do that. You got to keep in mind that not all lights are created equally, and not all of them are appropriate for using on wearables. So, first of all, LEDs. LEDs are great, right? Because they come in all different shapes and sizes and colors. I mean, literally, there's millions of options. If you want a specific LED, you can find it somewhere. And you can also get flashing LEDs, which have a chip in them. So you can just apply power, and they'll blink a certain pattern. Second one down on the right is, if you can see it, is there's a little black chip in it, and that's actually an integrated circuit. NeoPixels are really cool. That's the one on the bottom, because each LED is individually addressable, right? This means you can do all kinds of crazy patterns by just using 3 wires. This particular one is designed for you to sew things using conductive thread. And then middle, we have fiber optics. They're a really good option if you want to have like a long string of light attached to like clothing or something. This is because it's just a long plastic tube with a light in one end, which is cheap and really, really flexible, right? And some other options, it doesn't break easily. And if it does, it doesn't really matter because it's just a long plastic tube. I mean, you can chop it wherever you want. In the end, the light's still going to shine through it. And EL wire has a close that quite closely resembles classic neon signs. It either comes as wire, you can get it as panels, which are kind of similar to laminated paper. And the cool thing with those panels is you can cut them to pretty much any shape you want. However, as with most things in life, there are some exceptions, such as EL wire. While it is pretty cool, it does have some downsides that kind of detract from that coolness. Because of the way it works, you need a special power supply, which can create a quiet but noticeable high-pitched noise, especially if it's right next to your head. The other downside is that while it can flex, it's not meant to, and will break after multiple repeated bends, such as the kind it would experience on clothing, for example. Hence why I'd say fiber optics are a better choice. However, I would say it is fine for anything solid, such as like a headpiece or like a shield or something like that. It'll look pretty cool. And another thing to avoid is LED strips. While they're really cool and they're really cheap and they allow you to have just really long strands of LEDs, they're not designed for flexing. In this picture, in the picture at the top, you can see where the traces are cracked after repeatedly bending. Anything after this section won't work properly, if at all. Again, LED strips are fine for solid objects like props. However, I would avoid using them for any clothing. If you want a long strip of LEDs, I would suggest either a strand of LEDs, such as those ones up there, or even wiring your own. It's an option. And another thing to be wary of is power. I mean, yeah, you could put thousands of LEDs in your cool costume and it would look wicked, but then you'd have to power those thousands of LEDs, and that's going to need a big battery. And if your battery isn't big enough, well, you're going to start showering people with rocks. And then you're definitely going to want to need some of those refills of magic smoke. Especially on your first design, I would suggest keeping it simple. Small amount of lights can have a massive impact on the overall aesthetic of your costume and props, and will quite literally help you stand out among everyone else. So, now you got your lights ready? Sick. But you'll need to power them. Unfortunately and unfortunately, there are loads of types of batteries out there. Whilst it can and quite daunting, the main thing you need to worry about is the capacity and voltage. First off, alkaline batteries. You already know what these are. They're in everything, right? They're cheap, easy to find, fairly high capacity, reasonable capacity. Normal alkaline battery is about 1.5 volts. However, some are 1.2 for rechargeable ones like Loops, for example, which makes them great for using with LEDs, especially if you have a battery holder with 1 or 2 batteries. Then we have coin cells. They're also perfect for what we're doing, as they're again fairly easy to find, come in loads of sizes, and are usually really small. The voltage is normally 3 volts, which is again very useful for using with LEDs. Lithium batteries, they're great because very high capacity, especially for the size, and they come in like every shape imaginable. Probably the most common ones you're going to find are 18650 cells, which are the round ones that are slightly bigger than a AA, and they're mainly used in, well, watches, laptop battery packs, e-cigarettes, you know, all those kind of fun things. Then you've got LiPo batteries, which are all the kind of weird shaped ones. They're actually, the way they're made basically means that they can make them any shape and size they want. And they're in pretty much everything from your phone to laptops, to wireless keyboards, to RC planes and cars, and everything really. They're fairly easy to get hold of new. However, used electronics can be a good source of lithium batteries. But please, just be careful, because they hold a lot of energy and they can explode if mistreated. So if you're going to use a lithium battery, get a good charge controller. Adafruit Spark one have pretty good ones, please. And another option is USB battery banks. Like the thing is they're easy to find. They've got pretty high capacity for their size, and they got all the protection circuitry built in. I mean, all you need to do is either use a step up or step down converter, you know, for the 5 volts to whatever output voltage your device needs. So switches, they're really useful, especially for controlling things. They basically provide an interface between you and the electrical world, and there's loads of different types to choose from. I know it's exciting. Slide switches connect the middle pin, so that one at the top left. They connect the middle pin to either of the outside pins. And depending on where the slide is slid, depends on which one's connected. They're cheap, they're small, you can hide them in things, but they can be knocked quite easily, especially on the cheaper ones, which, you know, could be embarrassing at some points. Toggle switches, the ones just to the right of them, come in 2 types generally. A classic toggle switch, and the one on the very right is a rocker switch. It's basically the same thing, just a different box. Unlike slide switches, they're quite hard to accidentally knock out of position. They are designed to be panel mounted, which can actually look really cool in certain situations. I mean, who doesn't love big, like, flicky switches? Great. Push buttons. They come in a wide variety of shapes and sizes, such as momentary switches, or just push buttons, as they're sometimes called. They're the kind of buttons you find everywhere, from elevators to traffic lights to washing machines to whatever, right? You've got tack switches. They're the ones in the middle on the right. They're in essence momentary switches. However, they have a definitive like click when they're pressed. They're mainly used for like circuit boards and breadboards, but you can wire them to basically anything, and they're really cheap. And the latching switch, the one on the bottom right, is similar to a momentary switch in that you push it. However, when you let go, it stays on. And then to turn it off, you push it again. This is you know, useful in some situations. So this one's pretty boring, but I don't care. So first off, STE, that stands for single pole, single throw. They switch one wire off or on. That is the one at the top left. Don't worry, there isn't a test on this later. That would be just mean. DPST stands for double pole single throw. That is the one on the top right, I think. They switch one wire between two outputs. And the thing is, if you just wire one output, it just acts like an SPST switch. An SPDT switch stands for single pole double throw. They switch two wires off or on. That is the one on the middle left. The cool thing is each output is actually electrically separated, so you can switch two circuits at the same time. And finally, DPDT, one on the bottom right, is double pole double throw. I mean, it's basically just two SPDT switches stuck together, and then you have NO and NC, which stands for normally open and normally closed, respectively. So normally open is the one on the left at the top. That one, basically, it's open by default, and then when you push it, it turns on. And then the one on the bottom is normally closed, which means that it's normally closed, and you push it, it turns off. So, you know, depending on what you want to do, it depends on what kind of switch you want to get. So, wire. It's kind of like the foundations of your circuit. It connects everything up and holds it all together, in some cases, literally. And while there are loads of different types of wire, I would personally suggest going for a 22 gauge or 0.34 millimeters squared for the normal people out there. It's not too thick and bulky, pretty cheap, and you can usually get it on nice little reels like that. And you can find them in all kinds of colours, which is really useful, because otherwise you can have no clue where the hell your wires are going. They're just going to be all over the place. Trust me, I know from experience. Now you may be thinking, oh, stranded, solid, what does it mean? Well, they're both useful in certain ways, but for most of the work you'll be doing, I'd say go stranded. This is because it's pretty flexible. Whereas on the other hand, solid core is really useful for things like breadboards or like applications where the wire is actually a structural part of the circuit. The only problem is solid core can break quite easily when it's flexed a lot. So, you know, and you could also use conductive thread, especially if you're making a wearable. It basically acts like a thick thread, so you can sew it with a normal needle. But it conducts electricity, and you can use it with loads of modules that are designed specifically for sewing. So, connectors. Oh boy. You're going to need to connect your things, right? Yeah, you got your wires and stuff, but you don't want everything to be one big blob, because then it becomes completely unmanageable. So, and also it can help if you don't want to like, you know, solder everything together. You know, that you separate into all kinds of small sections and stuff. So the thing is quite a lot of modules already have connectors on them, right? Which again makes it really easy to just assemble circuits without having to solder anything. And here is a long list of connectors. JST-PH, top left. They're normally found on like batteries. JST-XH, top right. They are found basically everywhere. If you've pulled something apart, you've seen one of them before. They're quite cool because they latch. Well, they kind of latch. Stops them from falling out. JST-SM, up there. These connections they're normally found on like neopixel strands or EL wire. They're really good because they have an actual proper locking mechanism, which means they don't fall apart. RJ45 cables, also known as an Ethernet cable, also known as the internet. Really useful. You get 8 wires, nice conductor, and the connector locks, which is great. They're easy to crimp. You can find them anywhere. You have loads of them. They're sitting at the bottom of a cupboard. And the thing is just be careful about applying power over an Ethernet cable, because they're not all designed for it. It can go horribly wrong if you're connecting loads of things to it, but small things should be fine. Just check the spec sheet. DuPont connectors. They're the ones in the middle left. They kind of suck, really. Please don't use them. Just don't use them. They fall off. There's no locking. There's nothing. They just fall off, which is cool. But they're also used on like every module in existence. So, you know, and USB. It's a USB cable. A USB cable is designed for power, right? Which is great. I mean, you've also got, you know, if you wanna have two extra wires in there, you got 2 extra wires. They're great. They're everywhere. You can buy them from anywhere. Chop them up. Most of the colors are the same standard, but you know, always check it with a multimeter. So soldering. Oh, scary bit, right? Well, don't be scared. Come on. The thing is, quite a few of you out there are already really good at sewing, right? Like, if you can use a sewing machine, you can use a soldering iron. It requires a lot of the same skills. You know, especially the ones where if you do it wrong, it will hurt you and you will regret it. And the thing is, it doesn't even have to be that expensive. For example, top right, TS100, which is like the go-to hobby soldering iron nowadays. Round amount $50 to $100. For that price, you're getting something that's really small, has loads of tips available for it, and something that just works. Next, just make sure you have a good power supply. Ones like the one in the middle. Do not use generally the ones they come with. They're terrible because they're like these weird laptop style power supplies that aren't grounded. Just use an old laptop power supply. A lot of them are 19 volts. A lot of them are the correct connector size. Great, just do it. Or you could just get like an LED, a 24 volt LED driver, because that's good quality. You can also use battery packs as well, LiPo battery packs, especially if you're into RC, which is pretty cool. And also make sure you get a good stand. The stands they come with, the little weird fold-out ones, they're terrible. Please don't use them. You will burn yourself and or set your house on fire. Just get one of those. It's cheap. Please, just get it. Soldering. So, I would say just use the classic 60-40 leaded solder, right? You may think, oh, lead. Oh, you're gonna die. No, you're not gonna die. Just make sure you keep your brain about you. As long as you don't breathe it in, right? Well, breathe it in too much. Ventilation is really important. You can get tiny little soldering, like extractor fan things with filters on them. They're great and they're cheap. And also just make sure you wash your hands. And I mean, depending on where you live, your pipes probably have more lead in them anyway. Just one thing with solder: do not get plumbing solder. Don't do it. Most of the time, it's acid core, which means it'll literally eat away both the tip of the iron and the electronics themselves. I didn't do that by mistake. Trust me, I know what I'm doing. And then also, helping hands or helping octopus, whatever the hell that thing is. They're really cool because it means, you know, if like you've ever talked to someone who's like soldered before, they were like, oh yeah, I need loads of hands because I need one to hold the iron, one to hold the solder, one to hold the circuit board, and another one to like hold the other circuit board, and then you don't have anything left, which, you know, kind of sucks. So just get them. You can either get the ones at the top, they're really cheap. I'd say get the ones at the bottom because they're really cool because they're like all like malleable and stuff. But whatever you want, really. I'm not going to go into the slide much because it's really boring, unlike the rest of this presentation, which is incredibly exciting. But there's a few important things you need to know. One, passive components up there, well, some of them are up there, or passives. They can't actively control electricity, but they still have effect on the circuits. The main ones you will come across are resistors and capacitors. These components are the backbone of any electronic circuit. Resistors are used to limit the amount of electricity that flows through your circuit, and it converts it into heat. If it kind of like flows on the tap, you're slowing the flow of the water. and the amount of resistance a resistor has is measured in ohms. And the resistors are labeled on the side of the resistors with weird coloured lines because reasons. And capacitors are used to store and release electricity, kind of like a tiny little battery. Using the water example again, they act like a water tower or a tank. They're normally used to help smooth out the electricity going through a circuit. They're measured in farads and have a voltage rating, and some are polarized, so be careful not to put them in backwards. You don't want to do that. And the second lot are active components. They actively control your circuits, right? And normally they're made out of silicon, because silicon is magic. So some of these are diodes. They only allow electricity to flow one way, but not the other, which is really cool. And LED diodes, hence the name, light-emitting diodes. And they're a special type of diode that emits light when stuff gets put through them. Seriously, you could use them as normal diodes, but I don't know why you would. Transistors are like advanced diodes. They're kind of like a switch, right? So you can allow electronic components to control other electronic components, which is magical. And also it's pretty complicated. And transistors are in everything. I mean, there's like literally billions of them in the device you're using that's like the size of a few nanometers. It's kind of insane. And that's called an integrated circuit. And voltage regulators. They're used to like change the voltage of a circuit, either up or down. They're really useful if, for example, you want to run an integrated circuit which runs at 3.3 volts from USB, which is 5 volts. And that's just scratching the surface. There's way too much for me to talk about, and I will get kicked off if I keep going. So let's keep going. Hey. So this is the fun part. This is the part you're all waiting for, hopefully. So in this example, we're going to make Jethro here, over there. Yeah, he's going to have some sick glowing eyes. This isn't going to look very good. I'm just going to give you a heads up here. But it is a good example because, like, you want glowing eyes? Hell yeah, go for it. If you want glowing cheeks, sure. Do you want your fingers to glow? Yeah, do it. It's really simple. It's basically just an LED and a battery and a resistor, and like you can make that as big as you want as long as you have enough batteries and LEDs and resistors. And it only requires very basic soldering skills, which is great for beginners. So, what will we need? We will need some LEDs, naturally, to make it all glowy and stuff. I'm going to use some 5mm red LEDs, but realistically, you can use whatever color and size you feel like. You're also going to need some resistors. Maybe. You can find out what size you need by using an online resistor calculator, as the exact values can wildly vary unless you really want to calculate it by yourself. And then we'll need some batteries and a battery holder. In this case, we're going to use a CR3203 coin cell. However, if you want it to last much longer or much larger, you could use something like a 3x AAA battery holder, or even a AA battery holder. All you have to do is basically just change the resistor values. And most importantly, you need wire. As I said before, 22 gauge stranded core wires for this. However, it's the same process for any kind of wire. And for the tools, you're going to need a soldering iron. Obviously kind of important to solder things. And obviously solder to go with that. You need wire cutters, wire strippers, heat shrink, etc., etc. So, right, we got all the parts gathered up, right? But before you start going mad and just like sticking things together, we need to know what we're going to do. So we use the wiring diagram. So, as I mentioned before, we're going to use a CR2032 battery. I'd highly recommend getting a battery holder with a switch integrated into it. Now, the cool thing of using a CR2032 is it's 3 volts, which is perfect for an LED. And its internal resistance is high enough that you don't actually need resistors. So basically, the battery itself has an internal resistance, and because of the way coin cells are made, they have about 20 ohms worth of internal resistance, which is just about right for LED. However, if you're going to use something else, please, for LED, put resistors in, because you will explode it. And again, wire it up like the wiring diagram, and blah blah blah, different LEDs, whatever. Let's just get into this, because we ain't got all day, literally. So, just gonna make it clear, I'm not an expert on soldering. For a matter of fact, I'm not even that good. I have no clue what the hell I'm doing. But it's important that you know what you're doing. So, the first thing that makes a successful solder joint is you need to make sure you're using the correct splice. This one up there is known as a pigtail splice. And while it's fine for house wiring, it's definitely not good enough for the wiring that will be moving around all the time. So please don't use it. Instead, what you should be using is an inline splice, top right. It kind of makes it a pain to manage because there's like this weird long solid straight bit in the middle, but it's strong and it won't snap apart as easily when it's being repeatedly flexed. Or if you want to go completely mad, you can use the Western Union splice, bottom right, not splice. This thing isn't going to break on you anytime soon. For a matter of fact, it's used by NASA for spacecraft, so I think it's probably good enough for you. And remember, use heat shrink. And by heat shrink, I don't mean duct tape or electrical tape or blue tack or whatever. I mean like heat shrink, because tape goes weird, gooey all over the time, and you don't want to deal with that. That's not a good idea. The thing is it's really important to insulate your bare wires, because otherwise they'll start touching and shorting out and nothing will work, and you'll be very confused, and you'll spend hours trying to figure out why your things don't work. And that from experience. So, some assembly is in fact required. Duh. So now the boring bits out of the way, assuming any of this is exciting, let's get into it. So, first step, measure out your wire. You're going to need four in total, 2 red and 2 black. Normally red is used for the positive and black is used for the negative. So, what I'm going to do is take my wires, strip about 10 millimeters off each end using the wire strippers. You can use your teeth, but just use a wire stripper. Next, you're going to want to cut down the negative leg of the LED so that's about 5 to 7 millimeters, and then solder one of the black wires to it. Generally, the negative leg of the LED is the shorter one, and sometimes the top of the LED will have like a small flat on it. So, start by wrapping some of the strands of the wire around the leg of the LED, and bring the iron in. Hold it for a second or two, and feed some solder into it. It should melt almost instantly and go watery, wicking itself around the wires. Picture in the middle indicates. Just put enough to make sure it's fully covering the wires. Make sure it's actually connected. You don't have to make a massive blob. It's not required. If it doesn't work first time, just don't worry. Just put the iron on again. Boop. Done. Just don't put too much on. Just don't put too much heat on, because you can damage the LED or the wire, which isn't a good idea. And then you want to put your heat shrink over the joint, bottom right. And then you can either shrink it with a heat gun, or lighter, or even the soldering iron. But don't do that, because it doesn't smell nice, and it creates this weird gooey stuff on your soldering iron. If you do it, it's your fault. And now, just do the same for the red wires. And now we've got 2 LEDs with little wires on them. Cool. So, now that we have 2 sets of LEDs, we need to power them. So, first twist the ends of both black wires together. At this point, you're probably thinking, "Whoa, hold on a minute, Sam. You said not to do that. You can't just do that." And I mean, I did, but in this case, 1, it's fine, and 2, I'm the one doing the presentation. So the thing is, because we need to connect 3 wires, you can't really use an inline splice because there's 3 wires. So instead, this kind of splice will have to do. So at this point, you want to make sure you put your heat shrink over the wires. Otherwise, you'll spend the next 10 minutes fixing your mistake. Trust me, I know from experience. So strip a bit off the negative lead of the battery holder and twist it around the black wires, shown in the 2 pictures in the middle. Just make sure that you're actually connected to the negative wire. It's normally a black wire, or it's got dashes on it, or in this case, it didn't have dashes on it. If you don't know, use a multimeter and check which one's which. Really, you should just use a multimeter and check which one's which anyway, or just YOLO it. And then soldering is exactly the same as last time. Just make sure the joint is nice and wetted, as the cool kids call it. And make sure the heat shrink is a bit down the wire. Otherwise, it will shrink on the wire, and you won't be able to move it up. It's not good. Trust me, that definitely didn't happen to me. And then do the same for the red wires, and then turn it on. It doesn't work. Okay, well, it's kind of awkward, but you know, I'm pretty sure we can save ourselves, because one of the LEDs doesn't work, which is cool. So, but don't panic. Don't panic. I'm telling myself that right now, even though I'm still panicking. You can figure it out. First of all, check the connections. Make sure that all of your solder joints look good. You haven't missed any wires. You've actually got the battery plugged in. Blah 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 blah. So everything's connected, but make sure it's connected the right way. And make sure your battery isn't an upside out, especially with coin cells where you can easily go in both ways. Well, the LED is wired up the correct way around. Just believe me on that. So next, check the voltage with the multimeter. See if there's any breaks in the wires. Well, I get something across the wires, so that means there's only one test left, and that is to chop the component out, in this case the LED, and wow, would you look at that? The LED doesn't work. Incredible. So grab a new one, test it to make sure it does work, because that would suck. And then, you ready for this? You ready for this? Oh, it works! Incredible. I know this is the most exciting thing you've seen ever. And it looks really cool, and it didn't have any problems, because that made me look like an idiot that doesn't know what they're doing. And now, with this knowledge, you too can look as cool as Jethro. Sunglasses emoji. So finally, we're done. It's certainly been a long road getting from right at the beginning to here. But all I can say is, I hope you enjoyed this presentation, and thank you for spending your valuable time watching me. If you need any more information, or want to view the slideshow, or want to see some of the cool stuff I've made more in detail, visit my website, www.sciencegey.com, when I've finished uploading everything to it. And while there are loads of great sources of information out there, you know, some of the ones I would recommend: learn.adafruit.com, learn.smartphone.com. They sell the things, so they know how to use them. And I'd like to give a shout out to Echo for being a box man, Twix for not being here, Saber, Lucky, Neil, and the gang for not being here. And also, if you have any questions, ask away. There's a Discord channel. You can pop them in there, or there's a Twitch channel, and all the 4 people that are here. If you want to ask a question, go for it. So yeah. I'll tell them as a no then. Cool. Okay, so let's have a look, let's see if there's anything in there. Okay, there isn't anything in there. Let's have a look on the Twitch. And okay. Interesting. Okay, cool. Right, well, oh. Yeah. Okay, oh. Let's give him a minute. Hey, as you would expect, I was so good at doing this that everyone had a clue what they were doing. and they don't need to ask any questions. Or alternatively, it's because there's no one watching me. Oh, we have one from Twitch. Oh yeah, okay. So hit me. Oop. Not literally, don't hit me. That'll be kind of awkward. Yes, I have used Arduinos. I use them all the time. Yeah, they're really helpful because they're a bit more advanced because it involves coding and all kinds of fun stuff. But like some of the stuff you can do, mad, like it's insane. There are other microcontrollers available. Raspberry Pi, that's basically a computer. Teensy, again, they're really good. They're fairly cheap. Yeah, I mean, there's more out there than I can list. But microcontrollers are cool, but that's a bit more advanced. Okay. We'll get some questions in the Discord. Let's have a look. What metal should I use for soldering? Oh, come on, it's on the slide. At 60/40 lead/tin. That's 60% lead, 40% tin. The other option is you can get unleaded solder. Which is, or RoHS solder, which is again good, but it's got a much higher melting point. It's really mainly designed for companies making things. Let's see. What happens when life gives you lemons? You make lemonade, obviously. That's only partially related. Using NFC. NFC is cool. NFC is cool. Yes, NFC is cool. Especially if you want to have, so like, let's think of something. I don't know. Well, yeah, like NFCs and everything. I mean, your ID badge for work, that'll be NFC, or at least a variant of NFC, RFID, as the cool kids call it, radio frequency identification. It's really cool because it means you can, an NFC tag or a card or your phone or whatever can basically store data in it, and then your reader can read it. So I'll leave it up to your imagination to figure out what you can do, but there's lots of cool things you could do. USB power supplies? USB power supplies, that is a good question. I mean, anything that's not terrible, basically. The thing with USB is it's a pretty like well-defined spec, and it's been around forever. Good like brand names ones, especially the kinds that come with like your phone or whatever, like Apple ones, are actually really good. I know. I never thought I'd say that, but in this case, Apple stuff is actually really good. The voltage is really stable. And it's high capacity, but yeah, I mean, basically the thing to keep in mind, one, make sure it's not terrible. Just make sure it's not bad, and then also make sure it's got the correct ampage, because obviously if you're plugging in something that's drawing like 3 amps and it's plugged into a 500 milliamp USB charger, which is kind of the standard, you will blow it up probably. Well, you won't blow it up, it'll just turn off, but what's the difference, right? And if you're slightly related, if you're using batteries, Adafruit have a thing called a power boost, which is like it's an all-in-one like charger, uncharger battery thing, and it's really cool because they actually designed it for using with really long cables, so the voltage is slightly higher. That's really good, and it's really cheap. You can make some pretty good, portable battery banks and stuff like that. Let's see, is water wet? No, it isn't. It's moist. Moist. The black dot on the electrical diagram before the first LED. On the electrical diagram, let's have a look. Let's have a look at the electrical dot. The black dot. Ah, right. Okay, I know what you're talking about. Yes, the black dot is just to indicate that there's a junction. Basically, because otherwise because the problem is if you have 2 wires that cross each other, right, but they don't connect, it's a 2D diagram. How are you going to see that? So you put a little black dot, which is like a junction. What is mechanical for issues that I assume would be incredibly difficult to recreate in fursuit form, considering electronic would actually be incredibly simple, but it's only tedious at best. That's a really good question. I mean, well, I can't really say that because I've been working on a Protogen head for the past like 1.5 years. So that's more a me problem. That's actually really simple because, again, 2 screens, 3 screens if you want to go. I mean, you've probably seen the ones on the internet where they've got like this weird, like 600 custom built screens or whatever. Like, yeah, you could do that if you want, but you're insane if you do that. Like, 2 simple screens, you know, microcontroller, plug it all in. You're good to go, really. I mean, the most complicated part is the physical bit. That's the thing, is the most complicated part is the physical building of it, right? You know, you got to design it, and you got to build it, you got to do vacuum forming, you got to put the fur on it, all that kind of fun stuff. Like, the thing is really, it's all about what you think is hard, not what actually is hard. Yeah, because there's all different types of aspects to it. I mean, I've seen like something like I've seen someone who built a shirt, right, and they put loads of LEDs. They put a big NeoPixel grid in it, right, and like it basically turned it into a screen. Like, that seems, that's really complicated. But the most complicated part is the coding of it, and the coding of it has already been sorted because, you know, this is more Arduino kind of level, but like, there's libraries out there. There's thousands of libraries out there, and there's a library specifically for NeoPixels in a grid. And then you can basically just send you can just send a picture to it effectively, and it'll display it. You know, it's like, it's all it's not that complicated. Let's see. Do I have a YouTube channel? Yes, I do. It's basically got nothing on it. If you want to know the name of it, it's the same name that I use for everything. So it makes it nice and easy to find. And why not have 1 resistor before the LED of first having 2? That is actually a really good question that I kind of didn't think of. So that's more down to parallel versus serial. The thing is ideally, you want 1 LED per, 1 resistor per parallel string, effectively. The reasons are complicated, and I can't remember why. But I know they're complicated. It's all down to the way that resistance works and blah, 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 whatever. But generally, you do it like that instead of having it as one long, having 1 resistor and then loads of LEDs. Because the problem is the problem is you'd have to draw loads of power through that 1 LED, right? Because all the power adds up. So, you know, if you've got like 20 LEDs lined up, that's a significant amount of power. That resistor is probably going to melt and or explode, which would be fun. The whole point of using resistor is to lower the voltage going to the LED. It's a serial connection. Yes, yeah. I agree with that, dude. Let's see. I got a good question. If you're using a normal battery for LEDs, it will not work. You need a resistor, right? Yes, you would need a resistor. Because the thing is something like an alkaline battery, the resistance is so small that you will blow the LED up, right? Because the resistance is basically to stop too much power from going through the LED, right? Because theoretically, the LED will just keep pulling power forever and ever and ever until it melts and sets on fire. Which is generally, not a good thing. So you put a resistor in there and it kind of slows it down a little bit. So I know for car lights, you put them, you put them that way. They'll light up and they'll start flickering and exploding. Yes, they will, because they're drawing just like loads of power. Any more good questions? Come on, I can see people typing. Oh, people are typing. I'm gonna take that as a no. But if you do have any questions, put them in the channel, put them in the Discord channel. I'll probably read them and I'll hopefully answer them, probably with an answer that partially makes sense. So, thanks guys. I'll see you In the convention, maybe, possibly. If I'm there, go for it. Talk to me. I probably won't recognise you, but hey, you can still ask the question. So yeah, that's it really.